Salam and good day everyone. Okay, so for today, we are going to learn chapter 4 about enterprise modeling. Okay, so in this chapter, you will develop a logical model, of the proposed system and document the system requirement. Okay, so basically, logical model shows what the system must do, regardless of how it will be implemented physically. So for the physical model, it describes how the system will be constructed. So this is the outline, for this chapter. So at the end of this chapter, you will be able to define terms related to ER modeling, including entity, entity instance, attribute, relationship, and cardinality. And also describe the entity modeling process. You will learn how to draw an ER diagram. So and then data flow diagram. So basically you will be able to describe data and process modeling concepts and tools, including data dictionary, DFD, and also the process description tool. So first of all, what is ER diagram, or known as entity relationship diagram. ERD shows the relationships, of the entity set that's stored in a database. So an entity, it can be a person, it can be a place, thing, or event, for which data is collected and maintained. So basically, an initial ERD helps you understand the interaction among system entities and provides an overall view of your proposed system. So first ERD components, is the entity. So like I said before, an entity can be a real world object, either animate or inanimate, meaning that it can be easily identifiable. So for example, in the school database, students, teachers, classes, and course offered, we can be considered it as entities. So all these entities, they have some attributes or properties that give them their identity. So basically, entities are represented by a rectangle. So the first step is to list the entity that you identify during the fact-finding process. So you need to consider the nature of the relationship that link between them. Second component of the ERD is the attributes. So entities are represented by means of their properties. We call it as attribute. So basically, all attributes have values. For example, a student entity may have name, maybe class, and age as their attribute. So represented by ovals. Next component is the relationship. So the association among entities is called a relationship. So for example, an employee works at, a student enrolls in a course. So basically, works at and enrolls, we call it as a relationship. So you need to write works at or enrolls in this diamond. because a relationship represented by diamonds. Okay. Okay, next, okay, connecting lines. Okay, it is a solid line that connect attributes, okay, to show the relationships of entities in the diagram. Okay. So for the cardinality, okay, it specifies how many instances of an entity relate to one instance of another entity. Okay, so for the one-to-one, okay, one-to-one is one entity from entity set A that can be associated with at most one entity of entity set B. Okay, so for example, one person can have only one passport, okay, and one passport belongs to one person only. Okay, so for the one-to-many, okay, is a one entity from entity set A that can be associated with more than one entities of entity set B. Okay. However, okay, an entity from entity set B can be associated with at most one entity. Okay. So, for example, one student, okay, can have one class. Okay, but one class, okay, can have many students. Okay, there is one-to-many cardinality. Okay, so for the many-to-many, okay, meaning that more than one entities from entity set A can be associated with more than one entity of entity set B. Okay, so for example, one student can have many subjects, okay, and one subject can have many students. Okay, that is for the many-to-many. Okay, so there are many notation style, okay, for you to express the cardinality. Okay, information engineering style, okay, chain style, okay, Pacman style, and for this subject, okay, we will use the multi-style notation. Okay, so moving on to the steps to construct ERD. Okay, so first step is you need to identify the entities. Okay, so the first step in making an ERD is you need to identify all of the entities that you will use. Okay, so for example, here is the student entity and also the course entity. Okay, next thing is the next step is identify relationships. Okay, so what you need to do is look at these two entities, okay, and if it is related, okay, you need to draw a solid line connecting the two entities. Okay, and then the next step is describe the relationship. Okay, how are the entities related? Okay, so you need to draw an action diamond here, okay, between the two entities on the line, okay, that you just added here. Okay, so in the diamond you need to write a brief description of how these two entities related. Okay, so for example, here is student, enroll, course. Okay, so for the next step, okay, you need to add attributes. Okay, so any key attributes of entities, okay, should be added using oval shape symbol. Okay, okay, and the last step is for you to complete the diagram. Okay, so you need to put all the cardinality, okay, here. For example, many students enroll one course. Okay, okay, so finish for the ER diagram. Okay, So moving on to the data flow diagram. Okay, so basically system analysts use many graphical techniques to describe an information system. Okay, so a data flow diagram, okay, uses various symbols to show how the system transform input data into useful information. Okay, so basically a set of DFDs provide a logical model that shows what the system does. Okay, not how it does it. Okay. Okay, DFD use 4 basic symbols that represent processes, data flows, data stores, and entities. Okay, so there are 2 types symbol set. Okay, gain and Sassen symbol set and Jordan symbol set. Okay, so symbols are referenced by using all capital letters, okay, for the symbol name here. Okay. Alright, so for the DFD symbol, okay, the process symbol, okay, this is the process symbol. Okay, so basically process symbol receive input data and produce output. Okay, so it contains the business logic, okay, or we call it as business rule. Okay, so it referred to as a black box. Okay, where the inputs, outputs, and general function of the process are known, but the underlying details and logic of the process are hidden. Okay. Okay, next is the data flow symbol. Okay, as you can see here is the data flow symbol. Okay, so a data flow is a path for data to move from one part of the information system to another. Okay, so a data flow represents one or more data items. Okay, so the symbol for data flow is a line with a single or double arrowhead. Okay, as you can see here. Okay, so 3 data flow and process combinations that you must be avoided is the spontaneous generation. Okay, so it produces output but has no input data flow. Okay, like this one. Okay, for the black hole, okay, so it process that has input, okay, but there is no output here. Okay, so and then lastly is the gray hole. Okay, it has at least 1 input, okay, and 1 output, but the input obviously is insufficient to generate the output shown here. Okay. Okay, so moving on to the data store symbol. Okay, so data store, okay, as you can see here, represent data that the system stores. Okay, so it is a flat rectangle that is open on the right side and closed, okay, on the left side here. Okay, as you can see here. So a DFD does not show the detailed contents of a data store. Okay, so because the specific structure and data elements will be defined in the data dictionary. Okay. So a data store name, okay, is a plural name, okay, consists of a noun and adjective, okay, if needed. So for example, okay, data store symbol is student, okay, account receivable, okay, purchase order, okay, so meaning that it must be connected to a process with a data flow. Okay, so this is example of correct uses of data store symbols in a DFD. Okay, so for this one is incorrect uses of data store symbol. Okay, so moving on to the entity symbol. Okay, it is a rectangle. Okay, with a entity appears inside the symbol. Okay, so a DFD shows only external entities that provide data to the system or receive output from the system. Okay, so an external entity can be source or a sink or maybe both. Okay, but each entity, okay, it must be connected to a process by a data flow. Okay. Okay, so this is an example of correct uses of external entities in a data flow diagram. Okay, so this one is incorrect use, okay, of external entities. Okay. Okay, as you can see here, okay, this is the correct and incorrect examples of data flows. Okay. Okay, so moving on to the drawing set of DFD. Okay, there are 3-step process, okay, for you to draw the DFD. Okay, for the first step is you need to draw a context diagram first. Okay, and then after that, in second step, you need to draw a diagram 0 DFD. Okay, and after that, okay, you need to draw the lower level diagram. Okay, so there are few guidelines for you, okay, in order for you to draw the DFD. Okay, first, okay, you need to draw the context diagram so that it fits on one page. Okay, and second one, okay, use the name of the information system as the process name in the context diagram, and then, okay, you must use unique names within each set of symbol. Okay, meaning that, for example, okay, the process name is grading system. Okay, so notice that the process name is the same as the system name. Okay, this is because the context diagram shows the entire information system as if it were a single process. Okay, so for process in lower level DFD, okay, you need to use a verb followed by a descriptive noun. Okay, such as establish gradebook, assign final grade, or produce grade report. Okay, so and next one is do not cross line. Okay, meaning that restrict the number of symbol in any DFD. So basically, on lower level diagram with multiple processes, okay, you should not have more than 9 process symbol. Okay, so if more than that, okay, you need to reconsider your analysis. Okay, so another way to avoid crossing a line, okay, is to duplicate an entity or data store. Okay, so basically you need to provide a unique name and reference number for each process. Okay, alright. Okay, so for the first step, okay, the first step is constructing a set of DFD is to draw a context diagram first. Okay, so a context diagram is a top level view of an information system that shows the system boundaries and scope. Okay, So first of all, okay, you need to start by placing a single process symbol in the center of the page, okay, that represent the entire information system, okay. And then you need to identify it as a process 0, meaning that the numeral 0, not the letter O, okay. And then you need to identify the entities and the name and content of the data flow, okay, and also the direction of the data flow, okay. So how do you know which entities and data flow to place in your context diagram? Okay, so you begin by reviewing the system requirement, okay, your proper system requirement, then to identify all external data sources and also the destination, okay. So during that process, okay, you will identify the entities, okay, the name and content of the data flows, okay, and the direction of the data flow, okay, like I said before, okay. And then for the second step, okay, diagram, second step, DFD, okay. So diagram 0, okay, zooms in, okay. Oh, I forgot to put the arrow here, okay. So diagram 0 zooms in on the system and shows major internal processes, okay, data flows and also the data stores, okay. You need to zoom in, okay. So diagram 0 is an exploded view of process 0, okay, the contact diagram, okay. So diagram 0 also repeat the entities and data flow that appear in the context diagram, okay. So when you expand the context diagram into DFD diagram 0, okay, you must retain all the connection that flow into and out of the process 0, okay. Alright. Okay. And then, okay, a diverging data flow is a data flow in which the same data travels to 2 or more different locations, as you can see here, okay. So if same data flows in both direction, okay, you can use a double-headed arrow known as a diverging data flow. Alright. So for the third step, okay, you must use leveling technique. Okay, so leveling technique, it is a process of drawing a series of increasingly detailed diagram until all functional primitive, okay, are identified. So for the balancing technique, okay, it will maintain consistency among a set of DFD by ensuring that input and output data flows align properly, okay. So for the leveling example, okay, you can use a series of increasingly detailed DFD to describe an information system, okay, or in other words, it is also known as exploding, partitioning, or decomposing. This is the example of the leveling, okay, from contact diagrams, okay, to diagram 0 and then to the diagram 1. So you will start first with the context diagram and then zoom in to the diagram 0 and also the diagram 1, okay. Okay, so balancing ensures that the input and output data flows of the parent DFD are maintained on the child DFD, okay. So this example show the context diagram, okay, to diagram 0 and then to the diagram 1, okay. So moving on to the data dictionary, okay. So after designing the DFD, okay, you need to prepare the data dictionary, okay. So data dictionary, or known as data repository, okay, it is a central storehouse of information, okay. So an analyst uses the data dictionary to collect, okay, document and organize specific facts, okay, about the system. And the data dictionary also defines and describes all data elements and meaningful combinations of data element. Okay, so a data element, okay, also known as a data item or field, okay, it is the smallest piece of data that has meaning. Okay, so basically data elements are combined into records, okay, and it also known as data structures, okay. So a record is a meaningful combination of related data elements that is included in a data flow or retained in a data store. Okay, so it is important to document all of this in data dictionary, okay, including data elements, okay, data flows, data stores, processes, entities, records, and lastly, reports, okay. So as you can see here, okay, example of the data dictionary. Okay, so basically, using an online documentation form, okay, an analyst has recorded information for a data element, okay, named social security number. Okay, so later the analyst will create a data dictionary entry using a case tool, okay. Okay, so moving on to the process description tools, okay. So process description tools is document the details of a functional primitive which represent a specific set of processing steps and business logic, okay. So there are modular design, okay, structure English, decision table, and lastly decision tree. Okay, so for the modular design, okay, it is based on a combination of three logical structure, okay. Sometimes we call it as a control structure, okay, which serve as building blocks for the process. Okay, so this is the example of the sequence structure, okay. Second one is the selection structure, okay, and lastly the iteration structure. Okay, for the structure English, okay, you need to describe logical processes clearly and accurately. Okay, so you must conform to the following rule. Okay, use only the three building blocks of sequence, selection, and iteration. Okay, use indentation for readability. Okay, and then you need to use a limited vocabulary. Okay, so this is the example of the structured English statement. Okay, it might look like pseudocode in doing programming language. Okay, so this one. Okay, so moving on to the decision table. Okay, so decision table is a logical structure with all possible combinations of condition and resulting action. Okay, it is important to consider every possible outcome to ensure that you have overlooked nothing. So meaning that it can have more than two possible outcomes. Okay. Okay, for the decision trees, okay, it is a graphical representation of the condition, okay, action and rules found in a decision table. Okay, so you can use a decision table or tree. Okay, So basically, okay, during data and process modeling, okay, a system analyst develops graphical models to show how the system transform data into the useful information. Okay, so the end product would be the data and process modeling. Okay, it's a logical model that will support business operation that can meet the user requirement. Okay, so you need to remember, okay, data and process modeling, okay, it involves 4 main tools, okay, ER diagram, DFD, data dictionary, and lastly the process description. Okay, so that's all for today.